We are on lesson 5 of chapter 8, which is direct variation. First, we're going to determine whether a data set varies directly. Then we're going to find equations of direct variation. Then we'll solve a real-world problem. First, what is direct variation? Well, direct variation is a linear function that can be written as y equals k times x. And k represents the constant. And like the name indicates, constant remains the same. So in this relationship, you're going to multiply that same number times x, and so no matter what x is, y will equal x times k. A point of note is that direct variation always passes through the origin, 0 and 0. And if you think about it, that makes sense. When x equals 0, anything times 0 is going to equal 0. And the difference between this and your typical linear equation is usually you're adding something like plus 3 or minus 3. So when that addition is there, you have 0 plus 3, which does not make this 0, 0 anymore. But when there is no addition, that's what makes it direct variation, because 0 always equals 0. So for example, we have y equals 3 times x, so 3 became our constant. So y is always 3 times x. So when x is negative 2, negative 2 times 3 is negative 6. When x is negative 1, negative 1 times 3 is negative 3. 0 times 3 is 0. 1 times 3 is 3. 2 times 3 is 6. If you graph that out, you'll notice that it goes through the origin, 0, 0. And it all follows along this perfect line because x is being multiplied by 3. So now we get to determine whether a data set shows direct variation. If we look at shoe sizes, for example, a US shoe size is 39 for European size. When it's 8, it's 41, and 9, and 43, and so on. Is that direct variation? Well, you notice in the previous table we made, the relationship between 3 and 1 is the same. It's 3 times as big as 1. 6 is 3 times as big as 2. Negative 6 is 3 times as big as negative 2. Is the relationship between 7 and 39 the same as 8 and 41? We could test that with two ratios, right? We have 7 over 39. We have 8 over 41. If we'd cross multiply, 39 times 8 is 312. 7 times 41 is 287. Since 312 does not equal 287, this is not a ratio. As soon as you find one set of numbers that aren't a ratio, that means this is no longer direct variation. So we're going to say no. Now we have this table for sound intensity. Does the input signal directly variate with the output intensity? So for the input signal we have 6, the output intensity is 4.5. When it's 8, it becomes 6. When it's 12, it becomes 9. We could use that ratio method again. We have 6 and 4.5, so 6 over 4.5. Then we have 8 over 6. 6 times 6 equals 36. 4.5 times 8 equals 36 as well. So far, so good. You should probably test a couple more just to be sure. So if we have 20 over 15 and 28 over 21, we do 20 over 15, 28 over 21. 20 times 21 would equal 420. 15 times 28 also equals 420, meaning that these ratios are also the same. I can figure out the rest of these because I noticed that if you simplify all of them, they would turn into 4 over 3. These would all simplify into 4 over 3. Therefore, I know that this must be direct variation. So that's what we're going to say. Now we're actually going to write direct variation as an equation. So it says, given that y varies directly with x, find each equation of direct variation. So if y is 48 and x is 3, and we know this is part of a direct variation, we know that our direct variation equation is y equals k times x, and k is that constant. So we have y equals k times x. If we plug in numbers for y and x, we would say y equals 48, and that's the constant times x of 3. So what is that constant that is being multiplied times x to get 48? Well, we could divide both sides by 3 to solve that. So k would equal 48 divided by 3, which is 16. So 16 is being multiplied times x. So if I plug that into my equation here, it would be y equals 16 times x. You can always test your work by plugging in the 3 and the 48. 16 times 3 does equal 48, so we know we're good. Let's try that again for 15 for y and 10 for x. So 15 for y would be 15 equaling the constant times 10. We could find the constant by dividing by 10. So the constant equals 1.5. So we'd have y equals 1.5 times x. Now we have direct variation with a positive and a negative number. We have y is 63 when x is negative 7. We'd have 63 for y equals the constant times negative 7. Divide both sides by negative 7. So our constant would equal 63 divided by negative 7, which is negative 9. So I could plug that into the equation. We'd have y equals negative 9, which is the constant, times x. Now let's solve a real-world problem. It says when a driver applies the brakes, a car's total stopping distance is the sum of the reaction distance and the braking distance. The reaction distance is the distance the car travels before the driver presses the brake pedal. The braking distance is a distance the car travels after the brakes have been applied. Determine whether there is a direct variation between either data set and speed. So we're comparing either data set and speed. We're not comparing these two with each other. We're comparing it with the speed. If so, find the equation of direct variation. So first let's compare reaction distance with the speed. For example, when the speed is 15 miles an hour, the reaction distance is 33. When the speed is 35 miles an hour, the reaction distance is 77. 55 is 121. 75 is 165. Now let's just check to see if these follow the same ratio. Let's just do the first one and the last one just to be sure. So 15 times 77, that equals 1,155. 33 times 35 also equals 1,155. So these are equivalent ratios. How about 55 times 165? That equals 9,075. How about 121 times 75? That also equals 9,075. So these are equivalent as well. We could just test out these two if we want as well. 35 times 121, that equals 4,235. 77 times 55 also equals 4,235. Now that we've found that this is equivalent, we could plug in one of these relationships to find the equation. Let's make the distance y, which would be 33, and the speed x, which is 15. So 33 equals k times 15. Let's find k then by dividing by 15 on both sides. 33 divided by 15 is 2.2, so 2.2 equals k. If we rewrite our equation, we'd have y equals the k, which is 2.2, times x. So that's the equation for the blue. This is direct variation. Now let's test for the braking distance. When we have a speed of 15, the braking distance is 11. When we have a speed of 35, the braking distance is 59. So 35, braking distance 59. You could do the math to check this out, but I actually already could tell that since this number is bigger than that, and this number is smaller than that, these ratios cannot be the same. If you'd cross multiply and find that out, I'm sure that would give you different answers for cross multiplying here. That means that this is not direct variation. So for braking distance in that case, we're going to say not direct.